In this example, parts A and B, we want to find the inverse of the given function. So let's recall the notation and the concept behind inverse functions in general. And so the notation is g minus 1 of z. Okay, this doesn't mean 1 over g. This means the inverse of g. So it's the inverse function of g. And what it means is that this function undoes what g of z does. Okay, so in other words, doing g inverse of g of z, these two functions should undo each other and just give us back the original number, which is the same thing as saying if I were to take g inverse of g and then do g, those functions also undo each other. So for here, let's take a look at the function g. And the function g has several operations in a certain order that we could write these out. So for part A, what does the function g say to do? Well, the first thing we do is we take z and we multiply by minus 3. That gives us minus 3z. Then we add to 1. And that would give us 1 minus 3z. The third operation that we do here is take the square root. That gives us the square root of 1 minus 3z. And lastly, we add 5. So that gives us 1 minus 3z plus 5. Okay, that gives us g. So g can be thought of as a sequence of these 4 operations. And so to find the inverse, we can do the opposite operations in the opposite order. And that's going to tell us exactly how to undo the operations that g does. So for example, I first do the opposite of adding 5. That would be subtract 5. So I would take z and subtract 5. Then we do the opposite of taking the square root. And so we raise to the second power. And so that would give us z minus 5 squared. Then we do the opposite of adding 1, which would be subtract 1. So that gives us z minus 5 squared minus 1. And then lastly, the opposite of multiplying by minus 3 would be divide by minus 3. So that would give us, in the end, g inverse of z, which is z minus 5 squared minus 1, all divided by minus 3. Okay, and why this would be the inverse is doing these operations, these opposite operations in the reverse orders, one by one. We're going to undo the operation. So subtracting 5 undoes adding 5. Raising to the second power undoes taking the square root. Subtracting 1 is the opposite of adding 1, and then dividing by minus 3 is the opposite of multiplying by minus 3. So those sequence of operations gives us the function down below. And just a couple of things to point out before we move on to part B is that it's always a good idea to check our work. So by that I mean we could take G and compose it with G inverse and make sure that the condition that we get Z back, they undo each other, is satisfied. And then we can take G inverse, compose it with G the opposite way, and make sure that these undo each other and that the conditions for an inverse function are satisfied. Secondly, we can notice the following thing, and that is if I start out with the equation y is equal to the square root of 1 minus 3z plus 5. If I start out with the formula for g of z and I try and solve this for x, well, what would we do? We would first subtract 5 from both sides. Then we would square both sides. Then we would subtract 1 from both sides. And then finally, we would divide both sides by minus 3. And notice that matches what we got our first way, except we have a difference in what letters we've used for which variable, but that's more of a cosmetic thing. In the end, we get the same sequence of operations. So by doing things in the opposite order, the opposite things in the opposite order, that's the equivalent thing as solving the original equation for the input z. And when we go through that process, we get the inverse function down here. Okay, let's take a look at part B next. For part B, we now want to find the inverse of f of t is 7t over 2t plus 1. So again, it's the same idea in that we want to undo, so f inverse of t will undo f of t. So in other words, we want to do the opposite operations in the opposite order. And looking at the form of the function f of t, maybe it's not so clear what sequence of operations we've done to t in order to get f. At least it's not apparent in the way that this is written. So keep in mind that if we write this function as y is equal to 7t over 2t plus 1, and we solve for the input, we solve for t, that's the equivalent of doing the opposite operations in the opposite order. That's the equivalent of figuring out how do we undo the function f. So let's do that in this case. So what we could do is multiply both sides of the equation by 2t plus 1. And that gives us y times the quantity 2t plus 1 is 7t. And we want to solve for t here, so let's group all of our t terms on the same side. So that would mean first I'm going to distribute the y, and then I group all of the terms that have t on the same side. So I'm going to subtract 7t from both sides, and all of the terms that don't have t I move to the other side of the equation. So I bring the minus y on the other side, and this allows me to factor a t from every term on the left side. And now we can solve by t, for t by dividing both sides by 2y minus 7. In solving this equation, in effect, what we've done is the opposite operations in the opposite order. And so that will tell us exactly how to undo f, and that by definition is the inverse function. And so in the end, we've got this expression, and what's typical, it really doesn't matter what we call these letters, but typically we use the same letter as the input into the inverse. So what I mean by that is we would say that the inverse function of f, I would use t as the input. So instead of using the y that we found when we solved for t, I could replace those with t's. And this is a more common way of writing out what the inverse is. And again, it's always a good idea to check your answer by, in other words, taking a look at the composition of f and the inverse to make sure they undo each other, and taking a look at what happens when we compose them in the other way. So I'll leave that for you to check if you don't believe me, or it's a good idea if you want to practice your composition. But here we've found the inverse of f.